Hi, and welcome back to Introduction to IP Multicast. My name is Tim McConaughey. I'm delivering this breakout. This is part 4 of the breakout. In this part, we're going to be finishing up with AnySource Multicast, specifically Anycast RP. Then we'll be moving on to source-specific multicast. We'll cover IPv6 multicast at a high level, and then summarize the breakout. Without any further ado, let's move right into it. Now, what is Anycast? Anycast is a technique that we can use to advertise a particular function or service from multiple devices into the network, but using the same IP address. You see this a lot with DNS, especially. So like the world's DNS servers, the root servers, that's not one server sitting in a basement somewhere. That's a distributed network of servers that are servicing this exact same function, but are advertising itself as the same, singular entity. And then from a routing perspective, we advertise that same thing into the network, and then we just let the network choose the closest thing. It'll just route to the closest version of that. So with Anycast RP, we're going to advertise a rendezvous point address from multiple routers. And then we're just going to let the routing tables of our routers decide where to forward that packet to get to, say, 1.1.1.1. It'll choose its route. It'll use the unicast rib to figure out what's the best way, what's the fastest way to get to 1.1.1.1, not knowing that it's two different devices. Now, to use an Anycast RP, we have to make sure that all of our multicast routers are using the Anycast IP address as the rendezvous point. So we can do that anyway. We can statically set it. We can use BSR, we can use AutoRP, but they all need to select the same RP, and it needs to be that Anycast address. Because they're going to route their PIM messages to whichever is the closest, ostensibly. Whatever the closest version of 1.1.1.1 is where our PIM messaging will go. Now, that's good and bad because it can cause a problem, and see if you can spot it. Now, first, the source is going to send its multicast traffic to the first hop router. The first hop router is going to receive that multicast traffic and attempt to register it with its closest, with the RP. It doesn't know there's two different versions or two different routers with 1.1.1.1. It simply says, my configured rendezvous point is 1.1.1.1. I'm going to do a PIM register message to tell that RP that I have a source and a group for this particular group. And so it forwards it to its closest RP. At the same time, say, or maybe later, maybe before, we have a receiver that also wants to receive multicast traffic. It sends an IGMP report, which gets converted into a PIM join. And that PIM join is forwarded to 1.1.1.1 using, again, the best path to that in the rib for LHRB. Now notice, in this case, that both routers have made different decisions on where that RP is. So LHRB sent its PIM join to a different rendezvous point than the one that FHR registered the source. And this will never solve itself. This is not a problem that can resolve itself, because from each router's viewpoint, it's done what it was supposed to do. It just has no idea that 1.1.1.1 is distributed between multiple devices. So how do we solve this problem? Well, we solve it by making every rendezvous point, every device that's serving the purpose of a rendezvous point, know all of the sources that are registered. So we're going to use unique interfaces, because obviously we can't use the Anycast address to send messages between each other. We're going to use unique interfaces to send a particular message to all of the other Anycast RPs. So when any rendezvous point receives a PIM register for a particular source, in this case we're going to use MSDP, that router will use an MSDP, or Multicast Source Discovery Protocol. A source active message will be sent to any other configured Anycast RPs. So it's going to register it say on 4.4.4.4, and 4.4.4.4 is configured to send that PIM register to other Anycast RPs so that they'll become aware of that source also. Now, the message, of course, contains the IP of the source and the group address. So it's the same information that would come in a normal PIM register. And that's important when it comes time to deliver. Because if that RP has an active PIM join and an outgoing interface list has been built for those groups, that is what's going to trigger that rendezvous point to send its own PIM join towards the source and get the traffic running as it always has. So there's a couple options, right? There's an option called Anycast with PIM, and this is going to use the native PIM messaging to share the source information. There's MSDP, which we already talked about, which is a separate protocol, or we can use Anycast with PIM, where we're going to use the native PIM messaging to share our source. Now, we still require the unique addresses to do it, so they can send it to each other, so they can address that packet to each other. But we're still going to statically configure our neighbors. But when a PIM register is received, we're going to use native PIM messaging to forward that source of info rather than use a separate protocol like MSDP. So the RP, again, will forward that PIM register to the other RPs. And then, of course, they will acknowledge by sending a PIM register stop saying, okay, I now know there's a source, and then it will trigger its own join towards that source if it has any receivers. So this is another option, but right now at least it's an option only on the Nexus platform for IPv4. So this exists in IPv6 but not IPv4, and MSDP exists in IPv4 but not IPv6. So it kind of depends on which version of Multicast you're running as well as to which of your options you have. Let's talk about source-specific multicast. What is source-specific multicast? Source-specific multicast is the multicast solution that allows our receivers to signal the group and source from which they want to receive traffic. And that requires that our receivers know who the sources are without having to use a rendezvous point to discover them. The receivers have to have some way to understand where is the source. The receivers have to know the sources from which they want to receive a feed, and they have to use IGMP v3 to request that source and group pair. By default, we use a reserved multicast group address range for source-specific multicast, and that's 232.0.0.0/8. So if you see that as the group, oftentimes that's a source-specific join or source-specific flow. Because the S, G pair is specific, we could actually use a different S, G using the same multicast group without merging the streams together. I know in any source multicast I mentioned that any source is every source. This is kind of the opposite of that, where we can reuse the multicast group only because we can specifically ask for the source. How is it different than any source? Well, I just told you one of the ways that it's different. But the other way is that because we know where the source is, we don't need a rendezvous point. So early on in the breakout, when we were talking about the fundamentals of multicast, and we talked about how an IGMP report is forwarded towards the source, that was the source-specific setup, where we didn't have to use any source to discover that source. We could just forward it towards the source directly from the multicast router perspective. So in SSM, because we know who the source is, the PIM joins, the RPF checks, everything's based on the source, not on the rendezvous point. We don't need any kind of a star, G or any source join because we know exactly where to forward that PIM join and get that multicast traffic flowing. Now, source-specific multicast is based specifically on an S, G pair. So as I mentioned, if the group address is the same, the flow is different as long as the source is different. The multicast routers are going to treat that join as a separate flow because it is a separate flow. So you won't see any overlap in the mroute table. It'll follow the normal PIM join process again towards the source to get to the FHR and be added to the outgoing interface list. Now, because of this, because we don't need a rendezvous point, we don't need to worry about PIM registers and any of that with a rendezvous point, it's a lot less complex than any source multicast from a flow setup perspective. But the requirements to use source specific are much more stringent. First, we have to use IGMP v3, although in a minute I'm going to show you a situation where we can get around that. But usually we have to use IGMP v3 because only v3 has the field to request a specific source. And of course, the receiver has to know what source to request from. Because Multicast itself only supports discovery of sources using any source multicast, we need some method outside of Multicast to discover or determine who those sources are for the receivers so that they can request them. So if you think of IPTV, where we have a set-top box and you have a channel browser, that's something where we're using a browser to determine who the sources are that we want to listen to are, and then the receiver will send that source-specific join. Or sometimes there's like a website that you can go to and click on it. So for like a music feed or something like that, maybe there's a website you go to and you click on it, and that triggers a source-specific join from that hyperlink. Because of the nature of SSM, meaning that we're requesting a specific source, it's mostly useful for one-to-many applications. It doesn't really fit a many-to-many model very well. And the reason, of course, is that because we need that method outside of multicast to know who our sources are, if we're using a many-to-many model, often that requires a lot of updates to that channel browser or website or whatever it is that we're using to list the sources. Let's talk about a solution where we can actually use source-specific multicast even if our receivers don't support IGMP v3. How we do it is that we let the client issue its normal IGMP version 1 or version 2 report, but we know where they're going, basically. We know what source that they're looking for. So we're going to use the network to override that IGMP version 1, version 2 report. We're going to use some kind of a mapping setup. Either we're going to use a DNS service record or we're going to statically map it so that the routers that receive those IGMP reports will know what sources they're actually looking for. And then we're going to use that information to convert that version 1, version 2 report into an SSM PIM join. We're going to use that mapping database, or whether static or DNS, and insert the source that's being requested into the PIM join. And then it becomes a source-specific join. We don't have a lot to talk about when we talk about multicast and IPv6. Well, I need to correct that. We have a very large amount to talk about when it comes to IPv6 and multicast. Unfortunately, in an intro breakout, it's a little difficult to talk about IPv6 multicast. Whereas IPv4 sees multicast as a kind of an add-on solution, IPv6 has multicast baked right into the protocol. Pretty much everything that IPv6 does involves multicast because there's no concept of a broadcast in IPv6. So it really deserves its own breakout. But since we don't have a whole breakout for that, let's cover the differences between IPv4 and IPv6 and use that as a launching point to learn more about it later. In IPv6, we're using 128-bit addresses, of which we can use 112 bits for the group. From a routing perspective, the main add-on is that, of course, we can use the version 6 multicast address family. When we talk about version differences from a multicast version perspective, the main thing is, of course, that while multicast was developed while IPv4 was king, there's some technical debt that we can shake off when we move to version 6. So in version 6, we have no concept of dense mode multicast as an example. They just never bothered porting it over to version 6 because we didn't need it. We were already past that point. So we just lose dense mode in version 6. In version 6, we instead of using IGMP, we use something called multicast listener discovery. It's really just another name. If you look at the packets for IGMP and MLD, we're literally talking about the same packets. Now, version 1 of IGMP does not exist in IPv6. So again, we've shaken off some of that technical debt as we've moved to version 6. So MLDV1 is equivalent to IGMP v2, and MLD v2 is equivalent to an IGMP v3 report. From a source discovery perspective, in version 4 we have MSDP, and in version 6 we have something called embedded RP, where we can actually embed the rendezvous point itself inside an IPv6 address, and routers can extract that and learn the RP that way. So let's recap everything we've talked about. Actually, I should check. Is everybody still awake? Let's go over our multicast axioms. So from an IGMP perspective, remember that version 1 and version 2 are only used to signal for any source multicast because they lack the field to request a specific source. Version 3 supports source-specific multicast, and of course it also supports any source multicast as well. Remember that an IGMP report is where a receiver is raising its hand to receive multicast, and a query is where the router is checking the local segment to see if there are any raised hands. Let's talk about PIM. Remember that PIM joins are based on IGMP reports, and that when we do a reverse path forwarding check, we're checking the unicast best path to either the RP in the case of any source, or to the source itself with source-specific multicast. And let's go over the delivery order one more time. It starts with a report that gets converted to a PIM join. When we forward the PIM join, we're doing an RPF check against either the RP or the source. And then based on that PIM join, routers are adding interfaces to its incoming interface or its outgoing interface list. Then it forwards the PIM join to the next router towards, again, either the source or the RP. And traffic starts to flow when the first hop router, the router attached to the segment with the source, adds an interface to its outgoing interface list, either to the RP or directly to the receiver. So what's next? Where do we go from here? From a Cisco Live perspective, the next step might be taking a look at some of the other breakouts that use multicast, or specifically some that use our popular solutions. For example, with SD Access, we use multicast quite a bit. Take a look at that breakout. And of course, we use multicast in the ACI fabric as well. From a reading perspective, both of these books are excellent multicast books. IP routing on Cisco iOS, iOS XE, and XR is not specifically focused on multicast, but it does have an excellent chapter on it. Of course, developing IP multicast networks was written by Bo Williamson, who literally wrote the book on multicast. Both are out of print, but you can still find them, I believe, in Safari or O'Reilly Online or one of those online repositories. You can also watch the live lessons, Fundamentals of IP Multicast by Bo Williamson. Excellent video series. And by request, you can gain access to our Intro to Multicast demo. That's the demo I've been using to show some of our multicast solutions. If you're not familiar with dcloud, or you don't have an if you don't have an account on dcloud.cisco.com, you can head over there. It's free to sign up. Again, just kind of a recap here. This is the demo that we've been using throughout this breakout to show some of the solutions in flight. I want to thank you for attending this breakout virtually. And hopefully it was interesting and that you learned something about multicast. Thanks for watching. Thanks for attending Cisco Live, and take care.